Today, 6.4, day 2. Today we are going to be factoring polynomials of a higher degree and solving polynomial equations. So yesterday we did that with cubic functions. Today our focus will mainly be quartic functions. Quartic meaning it has a degree of 4. All right. Last chapter, you learned how to factor quadratic equations, and yesterday you learned how to factor cubic equations. You can sometimes factor polynomials of a higher degree by using similar techniques. So we'll take all this knowledge we've learned and apply it to higher degree polynomials. So like we mentioned in the objective slide, today we've got functions that have a degree of 4, or the highest exponent is 4. This problem we are actually going to treat very similar to problems that we did last semester. So kind of the equivalent problem to this that we saw last semester would be a quadratic. So if I just reduce the degrees of both the x to the 4th and the x squared, cut them in half, this is a problem we saw last semester. So if you don't want to copy down the last semester problem, you don't have to. I'm just trying to show you where this comes from. Okay, so let's do this last semester problem together first. Last semester, we would have factored this quadratic straight into 2 sets of parentheses. What would I have put in the front of both of those? An x. Can anyone tell me why I would have put an x in the front of both? There's not an x in the front of the problem, there's an x squared. Okay, so if I were checking my work, what would I do with these two x's? Multiply them, and x times x would give me x squared. Okay, so that's why we put those x's in the front. What about my signs? They're both plus. How do I decide what those numbers should be? Good. Multiply to 6, add to 7. I think I heard somebody say what they should be. 6 and 1. Do we all feel pretty good about that? Okay. To do number 1, like the actual number 1 from this semester, it's going to be extremely similar. We're going to factor it into 2 sets of parentheses. This time, I need my front 2 terms to multiply to x to the 4th instead of x squared.
Oh, x squared.
X squared and x squared. If I use an x squared on both of these, they would multiply to x to the 4th. Okay, what about my numbers in the back?
6 and 1.
Just 6 and 1. So let's talk about why. If I multiply 6 and 1, that gives me that 6 in the back, right? Let's multiply the whole thing out so I can show you exactly how this fits totally. So we already talked about multiplying the front 2 together. That's going to give me x to the 4th, right? And then we have to multiply x squared to the 1 back here. What would that give me? A 1x squared. We would also distribute the 6. So 6 times x squared would be a positive 6x squared. And then 6 times 1 we already talked about is a 6. And if I combine those 2 terms in the middle, what do I get? 7x squared. So this is like a step where I checked my work. Okay, because my check matches the original problem, I know that I did get it correct. So your actual answer is what we have in these parentheses up here. I'll just erase my distributing marks. So this is our answer. That's how we would factor it out. Number 2. Again, We don't have to do the last semester equivalent, but if we wanted to, last semester, this type of problem would have looked like x squared minus 3x minus 10. And when we factored into our parentheses what would have gone in the front, x and x to multiply to that x squared, what would my signs have been? Good. We need one of both, plus and a minus. If we multiply in the back to a negative, that's how we know we need one of each. 5 and 2 is what I'm hearing for our numbers. Which one should be positive? The 2 should be positive. The 5 should be negative. How do we decide that? Okay, the middle sign gets the bigger number. Okay. So yes, a -5 and a +2 would combine to give us a -3. All right, so we're going to do the same thing down here, except what's going to go in the front? X squared, because x squared times x squared is what gives me that x to the 4th. All right, and then the numbers and the signs don't have to change. Plus and minus, 2 and 5. Plus 2 minus 5. Again, we could multiply it all back out and show that we got the correct answer. We can check our work if we want to. I won't make you do that on all of these, but it is an option. There's our answer. Jacob?
X squared plus 2, x squared minus 4.
X squared plus 2, x squared minus 4. I would agree with that for an answer on number 3. That's a wonderful question. If you put x squared minus 4 and then x squared plus 2, that is perfectly acceptable. Okay, it does not matter to me as long as you have the correct sign with the correct number. Ian?
Okay, that's the only thing I'm confused. How are we getting this like 4? And do we just would divide 8 or something like 2?
The 4 and the 2? Is that what you're talking about?
Yeah.
These numbers here in the back?
Yes.
Okay, so that's the same thing we did last semester. They have to multiply to the number in the back, and they have to add up to the number in the middle.
Okay.
So 2 times -4 is -8, and 2 plus -4 is -2.
You got executed it as a practice.
Nope, I already passed out the ones I was going to pass out for the semester.
Mm-hmm.
Thank you, Jacob. Thanks for your homework.
You are welcome. Any other questions before we go to number 4? Nothing? Okay. Number 4 it is. Go ahead and give this one a try and we'll talk about it in a minute.
I got x squared plus 3 and x squared minus 9.
X squared plus 3, x squared minus 9. What do we think? Looks good to me. Ian?
We gotta put a squared on all of them.
The x squared?
We have to put that on every.
So, yeah, we need it in both sets of parentheses because that's how we multiply to an x to the 4th. Okay, so if we were to check ourselves, we'd multiply them back together. And it's got to be x squared times x squared to get us to x to the 4th. Any other questions before we keep going? That's one type of problem that we'll see. Okay, I personally think that these are easier than what we did yesterday because it relies so heavily on what we did last semester. So if you were good at factoring these last semester, now we're just dealing with x squareds instead of x's. Pretty easy transition. All right, let's keep going with the notes. Again, it's pretty straightforward. We want our polynomial to be in standard form. That's nothing new. We always like standard form. We factor the polynomial completely. Again, Nothing new. We've been factoring for months. And we use the zero product property. Set each part or each set of parentheses equal to 0 and then solve it from there. So really none of what we're doing is new knowledge. We're just applying it to new problems. Notice on example 5, we now have an equals sign in there. Equals sign. That's how we know that we are not just trying to factor this. We are actually trying to figure out what x equals. We're trying to get all the way to an answer. So we're going to follow those steps that we just had. We need it to be in standard form. Is this standard form? No, because we want it set equal to 0. How do we make that happen? Beautiful. Again, we've done this before last semester. Put it in standard form. Set it equal to 0. So we have x to the 4th minus x squared minus 12 equals 0. Remember, we won't always be able to combine like terms. That negative 12 cannot combine with either of the x terms. So it just gets put on the end. Are we in standard form now? Yeah, we're in standard form. We might not be representing every single degree, right? Like we don't have a cubed and we don't have a plane x. But that's okay because we're still in decreasing order of exponents and we're still set equal to 0. So this is standard form. We are ready to factor completely. So this is going to factor similar to problems 1 through 4. We put it in our double parentheses. Remember, it's still set equal to 0. What's going in the front? X squared on both. What are my signs? Plus and minus. Then I just have to determine what the numbers should be. Why did we think negative 4 and positive 3? Good. They multiply to a negative 12. They add up to a negative 1. Remember, if there's not a number written, that's a negative 1 there. All right, the next step. Oh, I don't think we're ready for our next step yet. We are not factored completely. Which of these two sets of parentheses can factor more? Second one. This is the difference of two perfect squares. So the x squared plus 3 comes down. X squared minus 4. Who can tell me what that factors into? Sadia?
X minus 2 and x plus 2.
Good. X minus 2 and x plus 2. So when it says factor completely, it means factor as much as you possibly can. We cannot factor x squared plus 3 anymore. That's as much as that one will factor. Now that we're factored completely, our next step is to...
Set it wrongly equal to 0.
Good. Set each parentheses equal to 0. So we've got x squared plus 3 equals 0. X minus 2 equals 0. X plus 2 equals 0. Which two are the easier ones to solve?
X plus 2 and x minus 2.
Good. The x plus 2 and x minus 2 are easier to solve, so let's get those done real quick. How would I solve x minus 2? Add 2. So x equals 2. That's one answer. Go ahead and box it or circle it. All right, what about x plus 2? How do I solve? Subtract the 2, so x equals negative 2. Again, go ahead, box it, circle it. That's one of your answers. To get the rest of our answers, we got to go back over here to this x squared plus 3 equals 0. We are going to solve this one using square roots. Remember, if we have an x squared and not just a plain x, we can solve using square roots by getting x alone, what's the first thing I need to do to get x alone? Subtract 3. So that means that we have x squared equals
-3.
-3. Then what do we do?
Square root.
Square root both sides. What do we notice about this problem?
Negative says
Ah, we've got a negative under the radical. So that means our answer includes an I. Okay, so x is equal to square root of 3i. But when we take the square root, we get a positive answer and we get a negative answer. So we put a plus minus out in front. Box it in. That represents the rest of our answers.
Man, that's a lot of work.
It is a lot of work. Do we have questions about it? Do we all remember the I process here?
Yes.
Okay, if you don't, I'll just make a quick note up here. The square root of -3 is equal to the square root of -1 times the square root of 3. That's not an I is equal to the square root of -1. So instead of writing the square root of -1, we write an I. We usually put it after, but we don't have to. You can put it before if you want. That's just like a reminder bubble from last semester. Okay, we're ready to move on? Are we sure? Okay, here we go. Oh, they've solved it step by step, so we'll just... There we go. I prefer to solve it rather than just have it typed up there. Example 6. What did they already do for you? Set it equal to 0 and put it in standard form. That was so nice of them. Now that it is set equal to 0 and in standard form, we are ready to not solve. My favorite F word, factor. Anybody new want to help me out with factoring this one? Someone I haven't heard from yet. Charles, we haven't chatted today. We need x squareds in both. Plus. I agree, we need plus signs in both. We need two numbers that multiply to 18 and add up to 11. What's it going to be? 9 and 2. Very good. They're both positive, so it doesn't matter to me. You put the 9 or the 2 in the front or the back. Can either of these be factored anymore? I'd be careful with your answer.
No, it can't because it's not negative.
Very good. We cannot factor this first one anymore. We're tempted to because we've got a squared and a squared. But that factoring pattern is for the difference of two squares, and this is a sum of two squares. Sum of two squares is not special. Poor thing. Not special. All right. If we can't factor anymore, we are ready to set him equal to 0. X squared plus 9 equals 0. X squared plus 2 equals 0. We're not ready to square root yet. What do we have to do first? So we're getting x by itself. First step to do that on the left side is subtract 9. X squared equals -9. Now we're ready to square root both sides. X equals 3i or... Okay, plus or minus 3i, a positive 3i or a negative 3i. Remember, if you have a perfect square number under your radical, even if it has an I, there doesn't need to be a radical anymore. 9's a perfect square number, so we can just get plus or minus 3i. Questions on that half of the problem? All right, going over to the other side. What do I do to get x alone? Subtract 2. X squared equals negative 2. What happens next? Square root. Very good. X equals plus or minus the square root of 2i. We know that when we have a negative under a radical, we're going to need to simplify to use I. The square root of 2 does not break down, so we just leave it as the square root of 2. These represent our answers. This is something that we might have mentioned briefly before, but possibly not. How many answers did we get here total? 4. What was the degree of our polynomial? 4. That's not a coincidence. Okay, unless you get a what's called like a double root or something, you get the same number of answers as your degree. So if your degree is cubed, you should get 3 answers. If your degree is 4, you should get 4 answers. Okay, unless there's a multiplicity of an answer, it's usually easy to see all 4 answers. Just a fun fact. Questions on 6 before we do 7? Nothing? Nothing. Okay. All right, here we've got example 7. X to the 4th minus 4x squared equals 45. I want you to take a minute and try this one on your own before we talk about it. All right, Ian, what's the first thing I need to do?
Subtract 45.
Wonderful. We subtract 45 to both sides. That gets it set equal to 0 and put in standard form. Minus 45 equals 0. Beautiful. All right, my next step is to favorite F word, factor. Can somebody new help me factor? Devin? X squared minus 9, x squared plus 5. I like it. Are we done factoring?
No.
No. We have the difference of 2 squares. All right, so we mentioned we need to factor the difference of 2 squares. That would be the x squared minus 9. I need a new volunteer to tell me how that would factor. New meaning we haven't chatted. I haven't called on you yet. Caden.
X minus 3 and x plus 3.
Wonderful. X minus 3 and x plus 3 is how we would factor that. The x squared plus 5 is going to stay the same because it is not able to be factored any further. What are we ready to do?
Set equal to 0.
Set equal to 0 and start solving. X minus 3 equals 0. X plus 3 equals 0. X squared plus 5 equals 0. Each set of parentheses gets set equal to 0 so we can solve them. All right, who wants to help me solve the first one? I'm in need of new hands. This is when I start picking on people. No one wants to solve x minus 3 equals 0. India's got this one. 3. We add 3 to both sides. X equals 3. What about the next one? Logan?
X 3.
Beautiful. We subtract 3 from both sides, we get x equals negative 3. So we can go ahead and box both of these in. These are 2 of our answers. How many answers would we expect to get altogether?
6.
4, because we've got our highest exponent of 4. So let's hope this last one gives us 2 answers. Anybody want to help me solve the last one? Emily.
X squared plus 5 equals 0.
Mm-hmm.
And then subtract 5 on both sides.
Good.
And then x squared equals negative 5, and then square root both sides.
I would agree.
And then I got x equals or minus 5i. Oh, square root of 5i.
Beautiful. Okay, so if we square root both sides, then we would end up with the square root of negative 5. But we know we can simplify that.
Yeah.
So x is equal to plus or minus the square root of 5i.